Hello students, today's agenda is to check homework. You will be choosing the appropriate formula and you will be able to do 7.6. Today students will be able to determine when the use of recursive and explicit formulas is appropriate. So let's start with a warm-up. And I want you to pause the video and try these exercises. Not only that, but I think I would like for you to decide whether each one of these is an explicit formula or a recursive formula. So pause the video and take a minute to do that. Okay, so the answers for the first 6 terms, for the first one are going to be 9. That's the initial point because it's given to me in here. But then they say that for the next term you're going to multiply by -1 and subtract 1 from that. So 9 times -1 is -9, minus 1 is -10. Okay, again, the first thing I do is multiply by -1, so that gives me positive times negative, negative. 9 times 1 is 9, and then it says subtract 1. So I have 2 negatives. It's an addition of negatives. Okay, so -9 minus 1 is -10. For the next term, I'm going to again multiply by -1. So -10 times -1 is +10. Minus 1 is 9. Okay. For the next one, since you see that we have 9, that's gonna end up with -10 as -10 in here. 9, -10, etc. Now, because these have f of 1 equals the initial point and f of n equals negative f of n minus 1, every time you have f of n minus 1, that means that this is called a recursive formula. Okay, again, it has 2 different parts. The initial point with f of 1 and the next part, it has an f after the equal sign. Okay, that's called the recursive formula. Okay, for number 2, we don't know the initial point because we don't have n minus 1 in here. If we had n minus 1 in the power, then this will be the initial point, but we don't have that. So to find the initial point, we're just gonna replace, because we're going to look for the first term, so we replace n by 1. So 3 to the 1 power is 3, times 2 is 6. Then to get the second iteration, we replace the n by 2. So 3 to the second power is 9, times 2 is 18. The third iteration going to be 3 to the third power, meaning 3 times 3 times 3 is 27, times 2 is 54. And we can actually see that the pattern is times 3 times 3, so we can figure out the rest without having to go back to the formula. Rather, we can just multiply by 3, and so 3 times 4 is 12, carry the 1. 3 times 5 is 15, and 1 is 16. For the fifth one, 3 times 2 is 6. 3 times 6 is 18, carry 1. 3 times 1 is 3, and 1 is 4. For the sixth one is 3 times 6 is 18, carry 1. 3 times 8 is 24, and 1 is 25. Carry 2, and 3 times 4 is 12, and 2 is 14. So those are the first 6 terms. And This doesn't have f of 1, so this is definitely not a recursive formula. And it has a multiplication with a power, and the power is an n, so that's gonna be explicit formula. And the type of sequence is geometric because we're multiplying. We are multiplying, so we can say that this is geometric sequence. Over here, we're multiplying and subtracting, so basically we have a little bit of both. We have geometric and arithmetic sequence. Okay, for the next one, we don't have, well, let's start with the initial point. For the initial point, it means the first one, so we replace this by 1. So 9 minus 1, that's 8. For the second, we replace this with 2. 9 minus 2 is 7. For the third one, replace this with 3. 9 minus 3 is 6. We notice that we're subtracting 1, so we can just subtract 1 to find the other one, which is 5, 4, 3, etc., etc. Okay, so that will be my first 6 terms. And again, it's not asking for the type of formula or the type of sequence, but I think it's good practice. So this is, because it's subtraction, it's arithmetic sequence. Because it doesn't have the f of 1 equals initial point, the initial point is actually 8. And it doesn't have f on this side of the equal sign, so that means that this is an explicit formula. Okay, so now let's go with our goal, which is to determine when to use the recursive and when to use the explicit formula. And we can say that this is all kind of like based on opinion. So take a minute to copy this. And so it says, consider a situation where you are counting calories. You eat 2,000 calories a day. If today is Monday, how many calories will you have eaten by Friday? Okay, so if today is Monday, Tuesday, Wednesday, Thursday, Friday, that means that you can just keep adding. Okay, for the second day you will have 4,000, 6,000, 8,000, 10,000. That's kind of like a way of doing the recursive, where you're just getting the previous number and adding 2,000, right? So we only need to figure out 2,000 more for 5 terms to figure out up to Friday. So we could say that this will be a good idea if we decided to use the recursive formula. Remember that the recursive formula is used when we're finding only a small number of terms. Okay, so in the recursive formula is f of 1 equals 2,000, and we would use f of n equals, it will be f of n minus 1 plus 2,000 that we're adding each day to the previous. Remember, this means look at the previous, in this case previous day, and add 2,000. Okay, so we can just have the initial point 2,000. For the next one, it says look at the previous one and add 2,000, so meaning 4,000. For the third day, or meaning on Wednesday, look on Tuesday and add 2,000. For Thursday, look Wednesday's calories and add 2,000. For Friday, again, look at Thursday and add 2,000 calories. So again, we can say that it's easier to use the recursive formula. Now consider this other situation. Consider a situation where you want to know how many calories you will have eaten in 4 years at 2,000 calories a day. So notice that they're telling you that you're ingesting 2,000 calories a day, but you want to know in 4 years. So how many days are there in 4 years? Well, each year has 365 days, and you multiply that by 4. However, every 4 years there is a leap year where they add 1 day to February. Okay, usually February has 28 days, but on the 4th year it has, or every 4 years it has 1 more day, so 29 days. So 4 times 365 is, 4 times 5 is 20, carry 2. 4 times 6 is 24, 26, carry 2. 4 times 3 is 12, 14, plus 1 is equals to 1,461. And that's a lot of days. I don't want to do a list like I was doing 2,000, 4,000, 6,000, 8,000, 10,000, that many times. I would have to do that, adding 2,000 that many times. So, how can I figure it out? Well, I can use the explicit formula. And what is happening? Well, for my explicit formula, I always have f of n equals the initial point, meaning what I intake the first day, which is 2,000, plus the 2,000 multiplied by the number of days minus 1. Okay, because I'm not counting that first day since it's already in here. And if I want to find, but for that, after 4 years, how many calories I have taken or eaten, then I'm going to put this as f of 1,461. So f of 1,461 is equals to 2,000 plus 2,000 multiplied by 1,461 minus 1, which is equals to, some people want to add this because it looks easier to do, but remember that you have to follow PEMDAS. You have to first do parentheses, then the multiplication, and finally this addition, okay? So don't go ahead and add this 2,000 plus 2,000. 1,461 minus 1 is 1,460. I bring down the 2,000. Now I'm going to multiply this, and it's positive times positive is positive. Since it has zeros, I can just multiply 2 times this amount and add the 3 zeros at the end. So it's 2 times 0, 0. 2 times 6 is 12, carry 1. 2 times 4 is 8, and 1 is 9. 2 times 1 is 2. And now I just add the 3 zeros at the end. This is the answer to this is 2,922,000 calories. So after 4 years, I will have eaten 2,922,000 calories. Now, some people say, how do you get a 2,2? Whoops. In here, all I'm doing is aligning this to the 2000 in here. I mean the other number. So 0 plus 0 is 0, 0 plus 0 is 0, 0 plus 0 is 0, 0 plus 2 is 2, and then I just bring down the 2, the 9, and the 2. Okay, so it's just a matter of aligning them. Okay, so here were two examples of where you can use the recursive formula and where you can use the explicit formula. As you can see, you use the explicit formula when you're trying to figure out for a day that is far away from now, like for in the long run, what would you have? Okay, for the recursive, it's when you only need a couple of terms, so it's for the short term that you can use the recursive formula. Okay, now we're gonna go the other way around, and I'm gonna make it easy in here. It says, now let's do this backwards. Take some time and come up with 3 scenarios where it's appropriate to use the recursive formula, and 3 scenarios where it's appropriate to use explicit formulas. And of course, you can use any school appropriate story. I'm just gonna give you examples that students came up with during class, and that way you can just look at them and come up with your own examples for your homework. Okay, so these are from 3 different classes, and I'm going to show you some examples for the recursive first. And so these are 2 examples. It says, I have 2 cats. My sister gives me 2 cats every year. How many cats will I have in 6 years? Okay, that's recursive because you only need to figure out for 6 terms. So the first one is 2 plus 2 plus 2 plus 2. So it's only for 6 years. And again, you don't have to solve for this one, but it's just coming up with a scenario. Okay, but the important thing is that you're just finding for 6 terms. The next one says, I have 3 cows. My dad gives me 3 more every year. How many will I have in 3 years? Again, in here, even shorter, you're only finding for 3 terms. Okay. These are other ones. You participate in the choir. You start with 2 members. You get 3 new members every weekend. And they said every weekend because Mass is like every weekend. And how many members do you have in 6 weekends? Okay, again, it's 6 terms that you have to find, so it's short. The cake factory produces 20 cakes per day. They started with 5 cakes. How many cakes will the factory have produced in a week? Meaning 7 days. So basically, you start with 5 and then you're adding 20, and you do that for 7 terms only. This is a little longer than what we're used to because we do either 4, 5, or 6 terms for the recursive formula, but it's just 1 more, okay? Okay, another example for the recursive is this one. You have 2 rabbits and they have 8 rabbits every year. How many rabbits will I have after 5 years? Again, you start with 2, multiply by 8, multiply by 8, multiply by 8, and do that only up to 5. Okay, so only 5 terms. Now let's do some examples for the explicit formula. And so they said in that class, they said that it will be the same story, but I want to know how many rabbits I have after 30 years. So how many rabbits will I have after 30 years? You don't want to do a list of times 8 times 8 times 8 30 times, right? So you would probably be better off if you use the explicit formula and just put f of 30 equals the initial point 2 times 8 to the 30 minus 1, and the 30 minus 1 will be the power. Okay, maybe I should write that one in here because that's kind of f of n is equals to the initial point, which is up there, the initial point, times 8, and then to the n minus 1, meaning to the 30 minus 1, meaning to the 29th power. Okay, and definitely for this one you will need the calculator. Okay, some other examples that your classmates came up with. I have 2 golden fish in my aquarium. They double every month. How many fish will I have in 10 years? Notice that it says they double every month, and they're asking in 10 years. So basically you're gonna have to multiply 10 times the 12 months in each year. And so in parentheses I would say that this means how many months in 10 years? Well, you just multiply by 12. 12 times 10 is 120 months. Again, you don't want to do a list of 120 terms, right? So that will definitely be better completed with the explicit formula. Okay, 2 more examples and then we'll be done. He says, I have 200 marbles. My cousin gives me 50 more every day. How many marbles will I have in 1 year? So it's every day. So if we want to know in 1 year, that will be after 365 days. What does that mean? You don't want to do that many numbers or terms, right? You can just go directly to figure out how many you will have after the 365 days using the explicit formula. Again, maybe I should write it in here. F of n equals the initial, which is I start with 200, and I'm adding 50, and then n minus 1, which will be the 365 minus 1, 364. Finally, I have 300 chocolates. I give away 2 chocolates to every student. How many chocolates will I have after I give, I guess, chocolates to 40 students? Okay, so again, that's f of n equals my initial point minus 2 times n minus 1. And this actually, the input represents the number of students that are getting the chocolates. Okay, so I hope this gives you ideas of what to write for your scenarios, and so that you can decide also which formula will be better off to find out. Okay, so have fun.